Okay, so we're still on 2.2, and we are still going to be describing end behavior and finding zeros of polynomials. We talked about on Friday there is at most n real zeros, but there are that many zeros. There can be real and imaginary, but real are the only thing we can graph, so that's a lot of times what we think about. And then at most, we have n minus 1 turning points, and that's where we have maximums and minimums, and it changes from increasing to decreasing. A lot of this stuff we've already talked about. And then how finding zeros is one of the most important things you will do in math. And it's something that you do over and over and over and over. Okay, so repeated zeros. If I have a factor x minus or plus a to the k power, and k is greater than 1, it's a repeated zero. So, if I have x minus 2 to the 6, it's repeated 6 times, because that means I would write this factor out how many times? 6 times. So that means that zero happens 6 times. It has a multiplicity of 6, whatever that multiplicity is. If k is odd, if your power is odd, the graph crosses the x-axis at x equals a. If k is even, okay, so odd crosses the x-axis, yes? If it is even, the graph touches the x-axis but does not cross. It bounces off. So x minus 2 to the 6, would the graph bounce there or go through there? Bounce, because it's 6. If it was 7, it would go through. So when I showed you the parent function of x squared and x to the 4th, and they all look like a parabola, the zeros were repeated. So x to the 4th would have 4, right? Zeros. And it would have x equals 0 4 times, and so it bounced off of x equals 0. That's why it came right back up. Now, I told you that's without all the junk on the back. So if it has junk on the back, that adds the other stuff to it. So my demonstration of this, does everyone have the top part written?
No.
No? Hopefully you're not writing it word for word.
Oh, I just wrote the whole thing.
Okay, so what you need to do is think about this like a door, okay? If I touch a door one time, what happens? It opens. I touch it again and it does what? Close. So that'd be the even, and what would my graph do? It would bounce off because it can't go through the door. And then I open it again, so it's 3. I can do what? I can walk through the door. I close it, so I'm at a power of 4. So now what's the graph going to do?
Bounce off.
Bounce off. Does that make sense?
Yeah.
Okay. Good. I don't have to bounce.
Can you just turn your
Just imagine she forgot to take that thing out and then she was just bounce off.
No. Okay, so real zeros of polynomial functions. Real zeros, not imaginary. We will deal with imaginary numbers soon. Okay, but right now when we graph something, it's important to know, yes, it's imaginary, I can't graph it, but we want to graph the real zeros. So, if f is a polynomial function and a is a real number, the following statements are equivalent. All these are the same. I've said them over and over and over. Solutions, x-intercepts, zeros, all the same thing, haven't I? When I ask for them, you need to know how to write them, though. We write them differently. So, x equals a is the 0. If I ask for zeros, you write it x equals whatever x equals. If I ask for a solution, that means I set polynomial to 0, yes? And I write it x equals a again. So solution x equals a. If I ask you for a factor, you write it as a binomial factor or a trinomial factor, whatever the factor may be. But you have to factor it when I ask for a factor. People, when I ask for factors, will give me zeros. Did they do that right? Did they write it correctly? No. So you need to make sure you're writing it correctly. When I ask for an x-intercept, we need to write it as a what? Point. And we've talked about that before. An x-intercept is something on a graph, and on a graph we write things as a coordinate pair, don't we?
Yeah.
So if I ask you for a factor, you're going to give me a binomial, trinomial, whatever factor. If I ask you for an x-intercept, you're going to give me a what?
A point.
A point. If I ask you for a 0 or solution, you're just going to give me what? X equals. They all are the same thing. I do every single one of these things the same, correct? I set it equal to 0 and I solve. Now, in order to get to a 0 or solution, I have to have what first? A factor, don't I? On a polynomial function, I have to go from a factor to a 0 or a solution. Or actually an x-intercept also if it's, okay, factors are kind of, I don't really, when I told you I said solutions, zeros, and x-intercepts are all the same thing, factors are how you get there. Like this is how you get to all the rest, isn't it? Okay, so factoring is how you get to all the rest. Good? We're good?
Mm-hmm.
You're not yelling. You're not, are you good? Okay, it says find all the real zeros and graph. Okay, so we're going to go through this. Is it an even or an odd function?
It's even.
Even.
Why is it even?
The exponents are even.
Not all the exponents. I don't care about all.
The first
The
exponent
first.
is even.
Not even
The
the
highest.
first. The highest.
Yeah.
Yeah.
that's
Because
what
I should write it in the correct order, right? So first I should have asked, is it written in the correct order?
Yes.
Yes. Okay. So is my first is my highest degree even?
Yeah.
Yes, so it's even. So that means it's going to do what? Show me with your hands how this is going to end. Either or. I don't care which direction. Okay. It's going to be my dance, right? Up or down? Both up, both down, because even look nice. They're symmetric. Well, they're not symmetric if they're parent functions. Okay, so we know it's going to go up, up, or down, down. Which one is this going to do?
Down.
Down, down. So it's going to go down, down. This is my work, guys. Writing the problem and like this is my work. That's the end behavior. That's like 10 problems, not 10 problems, but it's like 5 or 6. Okay, so it's going to go down, down. And so now I need to find zeros. How do I find zeros of a polynomial function? Set it equal to Zero. and solve. And solve, I have to factor, correct? Okay, so I have negative 2x to the 4th plus 2x squared. Can I factor something out?
You take
We just
2x
combine
squared
it.
out.
You can't combine them, they're not like terms. You got the 4th and you got
Yeah,
squared.
yeah.
So I can
2x
factor
squared.
out a negative 2x squared. So then I'm left with x squared plus 1?
Yeah.
Oh, minus 1. Minus. Why is it minus, not plus?
You can take it a negative.
I factored out a negative. Okay, now what do I do to these? They're still equal to 0, so I set them what? Both equal to 0, don't I?
Yeah.
Now, this isn't completely factored yet because I have x squared minus 1,
Which is the perfect square.
which is the difference of squares, yes? Which can be factored to x plus 1 and x minus 1.
Where'd the one come from?
Because 1 times 1.
No, that one, this
Yeah,
one?
yeah.
When you're factoring, you divide, so I have 2x squared divided by 2x squared is 1. So now I said every single one of these equal to what? 0. When you get good, you should just tell me the answer to that is plus or minus 1, correct? Okay, but for right now, so we have x equals, so this will be positive 1, this will be negative 1. So negative 1. How about I put the 1 then? What's this going to be?
0.
0.
Why?
Did you say y? Because I have 0 equals negative 2x squared. And so I would divide by negative 2x, and it would be x squared equals 0, and the square root of 0 is 0. And it's actually plus or minus 0, right? But that's just 0. How many times?
Twice.
Why is it twice, guys?
Because it's more than 1.
The exponent's 2.
Small.
Okay, and 1. So negative 1 had a multiplicity of 1, yes? I had one of those factors. And 1, I had one of those factors. But my 2 had, how many, or my 0 was a multiplicity of what?
2.
2. So I just do this like up top of it, so you know it's 2. I think the book writes out mult, like M-U-L-T, 2. If you need to do that, okay? But what does that tell me that this graph is going to do at 0? Is it going to go through 0?
No,
No,
gonna bounce.
It's going to
up.
bounce. Okay, so we know it's going to start down and end down. We know negative 1 is going to be important. We know 0 is going to be important. And we know 1 is going to be important.
It's gonna go
So it's going to start down here, yeah?
Let's take
Go
it.
up.
It's going to go up and then come down, bounce,
Yeah.
and then come down.
It's an M.
You just guess how far up it goes?
Right now, that's for calculus. We'll figure out how far it goes up in calc.
Yeah.
We'll do a derivative and find the zeros of the derivative, and I can tell you that point. Yes?
So with your factoring, you put x minus 1 and then x plus 1. Where do you get the plus at?
Because this right here is x squared plus 0x minus 1. What are the factors of 1 that have a difference of 0? 1 and 1. That's why that works that way. It will always work that way. So, graphing hopefully should be getting easier for you. We're getting more details, and you just got to get over the point that it doesn't have to be exact. It is not an exact science. These are exact, like those are important, okay? But other than that, it's not an exact science. Now, if we came out like 7/8 on one of these, we'd write 7/8 and do our best. Okay, 7/8 is almost 1. I mean, I'd sketch the graph and then put 1 on the other side of it. It doesn't have to be, we just won't need the shape, what's going on. Oh, here, I'll review. What is my domain of this function?
-1.
My domain, what x's can I throw in this?
Negative 1 to 1.
What is my domain? Do I have any restrictions on negative 2x to the 4th plus 2 times x squared? Any restrictions on what I can plug in there? No. So my domain is
All real numbers.
all real numbers.
Why do you have no restrictions?
Because there's no fractions, there's no square roots. It doesn't apply to an application problem.
In the original problem.
In the original problem, there's no fractions, there's no square roots. Well, there's no variables in the denominator, I should say that. Fractions don't constitute. There's no variables in the denominator, there's no square roots with variables in them. And it's not in an application problem that has restrictions on it. Now, I could ask you the range, but the problem there, I need to know what. I need to know what that is, right? So the range is everything down here, whatever that is, right? Usually, from here on out, it will be only domain I'm talking to you about, unless it's like a parabola or you're graphing it, or, it's not going to be huge, difficult problems, and then I ask you the range. I'll just ask you domain, because I'm looking for the restrictions. Okay, use the leading coefficient test. Find all the zeros, determine the multiplicity of each of the zeros. You know what? I listed all those out. We just did them all. We did all those. Leading coefficient test, what does it tell me?
If it goes up or down.
It goes up or down. That's all it tells me, right? Okay. Did we find all the zeros on the last problem? Yeah. And did we say the multiplicity of all the zeros? Yeah. And we graphed it. Oh, we didn't do the number of turning points. Let me go back. What should the number of turning points be if the highest power is 4? 3. Do we have 3? 1, 2, 3. Okay. So we have g of x equals negative x squared minus 10x minus 16. Even or odd? Even. So it's going to either up, or down, down.
Down.
Why down, down?
Negative in front of the x.
Because there's a negative in front of the x. So it's going to be down, down. And that's the leading coefficient test, yes?
Yeah.
Got it done.
So anytime there's a negative in front of the x, it's always down, down.
Well, on an even. But on an odd, it ends down, so it started up.
Like when you say on an even, you're meaning x.
With the degree, yeah, the degree is if it's an even function. Okay, so now I need to find all the real zeros. How do I find real zeros?
Set equal to 0.
Set it equal to 0, factor, and then set my factors equal to 0, right? Okay, before we factor normal, what do you guys want to do with this?
Get rid of
You want to factor out that negative, don't you? So I have x squared minus 10x plus 16. So 1 times 16 is 16. The factors of 16 that add to 10.
8 and 2.
8 and 2. And the factors of 1 are just 1 and 1. So 8 and 2, and they are both what?
Positive.
Negative.
Negative. This positive tells me they are both the same as the middle one. So they're both negative. So I factored. Now what?
Set equal to 0.
Set them equal to 0. What is this one that's set equal to 0?
The positive.
Nothing.
0.
Because it's
There is something there. What is the number there? Is what I want to know.
So equals.
Negative 1?
Yeah.
So
Okay, does negative 1 equal 0 ever? No. If there was an x here, would it equal 0?
Yeah.
Yeah. Okay, so x equals,
1.
nope,
8 and 2.
8 and 2. Where'd you get 1?
From the front, right?
No, the front, that's negative 1 equals 0, and we just discussed how negative 1 can't equal 0.
Oh,
Okay. Multiplicity of both of those? Just 1. Okay. Again, if it says discuss the multiplicity, if it's just 1, you don't need to say multiplicity of 1. That's just, okay. Turning points. How many turning points am I going to have? 1. Okay. It is a parabola, so it should go, well, this one's going to increase to our max, and then what? Decrease. That's it. Okay. Since it is a parabola, and since we always can review, right? Anybody remember how to find the maximum? What do I use? The formula? The max A or
2
minimum?
A.
Close.
negative b over
Negative b over
2.
2a.
Oh,
It's the first part of the quadratic formula, right?
Yeah.
That negative b over 2a. So let's go ahead and do it. We can do it, right? And we know it's going to be a max because this is opening down, right? So then it's going to be a maximum. So the max A, not max x, sorry. It's going to be negative b, so b is what? 10, so it's going to be negative 10 over 2 times a 2
Negative.
times negative 1. So negative 2, so it's going to be at what?
5.
5. Not negative 5.
5.
Now, how do I find the y?
But,
Put the 5 in.
Put in, right. So I have f of 5. So 5 squared is
25.
25, and it's going to be negative, right? And then 5 times 10 is 50. And then minus 16. So 25 minus 16 is 9. So my maximum is at 5, 9. So now do I know how far up this is going to go?
You don't have to do that during this assignment.
No, but you might want to take a minute to do it so you remember it.
Wait, so our point is 5, 9 then?
For the maximum, yes. Okay, so now so 1, 2, 3, 4, 5, 6, 7, 8. So I need a 0 at 2. And I need a 0 at what?
8.
8. Oh, well, I'm going to just do this, do that, and I'll show you what. And then I'm going to say 9. I'm going to draw my parabola, and then I'm going to come over here and say 9. See that? I made my scale fit my graph, not my graph fit my scale. Because if I try to make my graph fit my scale, I get really funky shapes. Doesn't always look the prettiest. And there's my graph. I would encourage you a couple of times to find the maximum or minimum so you can remember that formula. Because you will need to remember it. And it's just what part, where did I get that from? The quadratic formula. You guys remember the quadratic formula? Negative b plus or minus
Square root of what is it? B
Negative.
minus
b
squared
squared minus.
4ac over 2a.
You do need to know this. Not gonna give it to you. When do I use it?
Find x-intercepts.
Find x-intercepts when I can't factor, right? Now, could I use it if what I have to factor is really difficult to factor and I don't want to mess with it? Yeah. You just wouldn't have factors. You would actually have the values. So if you needed the factors, you'd have to put them back in. Okay, same thing. Want to try it on your own?
Yeah. This is a hard one.
The factoring might be a little difficult. Do the first step. Do leading coefficient, number of turning points, and then, oh no, this one should be easy to find. Maybe. I'll just let you try. I'll give you a head start. How about that?
you?
What?
Why would you not want to take 4 in front of like the parentheses, like negative 4x and then?
'Cause you can't
Because
take 4
4
outside
doesn't
15.
go into 15. Yeah, if it was 16, definitely take a 4 out.
I could never do that.
Okay, did you get 6 and 10?
No, I don't get how that goes into 15.
No,
It
you take 4 times 15, you get 60.
Yeah.
You need the factors of 60 that have a difference of negative 4.
Oh.
And how did you get 3 and 5 out of 16?
Okay, because this is A, yes, and this is C. These have to be the factors of A. These have to be the factors of C. And this multiplication and this multiplication combined gives me negative 4. So I need to get 6 and 10 out of the factors of 4 and the factors of 15. So in order to get 6 and 10, I knew I couldn't use 4 and 1, so I had to use 2 and 2. And 2 times 5 is 10, and the other fact, and 2 times 3 is 6, and 5 times 3 is 15. You're having to just like when you do long division, you have to multiply the whole time. We're doing division here, we have to be multiplying the whole time.
Well, I'm honestly still confused about the arrow.
Okay, it's
I
odd.
got that, but I guessed it.
It's odd.
Okay.
Odd always starts and stops in different directions. But it's negative, so it means it has to end down, so it had to start up.
Oh.
That it's really the end behavior. So the most right behavior is told to you by that.
Okay, so say it was a 2, like say, or a 4. So then you know that it would have to end and start the same way.
Right. And it's negative, so it would end down, so it has to start. Okay. So now I have to set every single thing equal to what?
0.
0. So I get 0. And then I would subtract 3, divide by 2. So negative 3 halves. Add 5, divide by 2. I'm just solving the equation, right, for x. I'm going to have 2 turning points because it's n minus 1, right?
Yeah.
And I always like to write them in order. If it was on my paper, I'd have to fix it somewhere.
Wait, why is it 0? Because you have negative x.
Right, but I have negative x, so I would divide both sides by negative 1. So x would be equal 0. Before I had just negative 1, I didn't have a variable with it. Okay, so negative 3 halves is 1 1/2, correct? So negative 1 1/2, 0, and then 5 halves is 2 1/2. Okay, there's not a right answer here on where you place it, but there's definitely wrong answers, right? If I was closer to 3, would that be wrong for 2 1/2? Would it? Yeah. It's not. It's the middle. Okay, so I'm starting up, and I'm ending what? Down. So I start from the top, I'm decreasing, hit a relative minimum, come back up, I'm increasing, hit a relative maximum, and come back down. And if you don't like how it went through, just make your point a little bigger. It's a sketch. My domain here is still all real numbers, right? Because I don't have any variables in denominators, I don't have any square roots. And my range would be dictated by this maximum height here and this minimum height here. It'd be between there. Actually, no, it wouldn't, because what does this graph keep doing? Going down and down. So what is my range? All real numbers as well. Now, if I ask for a range in a certain domain, then it would be changed.
How did you know where your turning point was?
Because it's just that maximum. Again, we're not calculating what this is, and we're not calculating what that is. We're just going up some and down some. That's for calculus. We could do it if you'd like.
No.
I don't think we're ready quite yet for that. Right now, we need to just get the shape and the zeros. We need to work on what we're ready to do. We'll add in the other part later. I might have one more, or I might not. I do. Okay, what's wrong with this one before you even write it
Not in
down?
order.
It's not in order. So I should write it in what? Order. Writing it in order is always something you should be aware of. Because in this case, those are both even exponents, correct?
Yeah.
So you'd have the right shape, but would you have been opening it in the right direction? No, you wouldn't have opened it in the right direction. Would you have the correct number of turning points?
No.
No.
You can take 3x squared out of
Yes, you can. How many turning points are we going to have before we go?
it. 3.
3? Okay. So Connor says we need to factor out a 3x squared. Everyone agree? So that gives me 1 minus 16. Oh, that doesn't just give me 1. It gives me x squared, doesn't it? So x squared minus 16. Okay, am I done factoring?
No, because those are,
Difference of squares, right?
Yes.
Okay, so if it's a difference of squares, it's going to be the factors of 16 that have a difference of 0, which are what? 4 and 4. So it's going to be 3x squared, x plus 4, and x minus 4. If I FOILed this out, I would get this. I promise you. Now what do I do to all those?
Theta sum equals 0.
Set them all equal to 0.
0,
Negative 4.
You have 2
0.
multiplicities of 0.
Nope, I don't have, all my multiplicities are 1.
The one on the side there.
Oh, yes. Thank you. You're right. I thought you were talking about these.
No.
Yes, this is a multiplicity of 2 because of that. If that was a multiplicity of 3, it would be 3. So what's it going to do at 0 then?
It's gonna bounce
It's
off.
going to bounce. You're more concerned about the multiplicity when it's even, correct? Because you naturally go through a 0, don't you? So, but if it's even, we've got to bounce off of that. Okay, so you guys graph it. Oh, we didn't do end behavior. Leading coefficient test. What's it going to look like? Up, up?
No, John, down.
No.
Oh, yeah. 'cause
Up,
it's not
up.
half of that.
If you looked at the first one, you'd be down, down, and that's wrong. You guys ready to check it? Is that a yes or a no?
Is there something wrong with this?
Wrong with what?
Oh yeah, it bounces.
Because you were going, I can't end in the same direction, right? If you were doing this problem being you didn't bounce through that 0, did you end the way you should have?
No.
No, because you cannot go through the x-axis without a door. And if you did that, you would have come up here and gone back down. And what do we know about that shape? It has to go where? Back up. And it couldn't have because it doesn't have another 0, does it? Okay, so your graph, when you're graphing your graph, you kind of should know if you're right or wrong when you're done with it. Questions, guys? Okay, now it says find a polynomial function that has the given zeros. So I gave you the end. You got to go back.
No.
Backwards?
Where do we get zeros from?
Your
Your factors, yes?
Yeah.
So I had to add or subtract over, so now I need to add or subtract back over, yeah? So the first factor was just x equals 0, right? So just x. What factor did 8 come from?
Negative 8.
X minus.
X minus 8. So now I have my factors. How do I get my polynomial?
Multiply.
I multiply.
So it'd be
Distribute
x squared minus 8.
8x.
Okay, that was easy, but the next one.
And the next one's going to be just as easy.
I feel like in the book when I do them alone, they will be harder.
X outside parentheses.
X from the 0, yes? What factor did
X plus 4.
X plus 4? Just doing the opposite to get it back in a factor, right?
X plus 5.
X plus 5.
X.
Now, from my expert opinion, I would FOIL that first, then distribute an X.
That's what I was.
The worst part of this problem is going to be multiplying it out.
That's what it equals to.
If you do it right.
Yeah, I got it.
You get x cubed.
Because you have to distribute this X. I just gave you the end. I just gave you the end. You should have x squared plus 9x plus 20. And then you distribute that final x and you should get x cubed plus 9x squared plus 20x.
Why'd you do? Oh, wait,
So the more zeros I have, the more factors I'm going to have, the more steps I need to go through to do this, right?
Is it gonna be more than 3?
I think you have 1 maybe with 4. But if you have 4, you do these 2 and these 2, and then what do you do with them? You
Times them
multiply them together. You don't do it all
So
at
that
once.
wouldn't even be that bad.
No. You just have to be procedural about it.
So
Um,
f of x is equal to x cubed.
Yeah, f of x. I wanted to make sure the next slide was there because I want to do an example of this. Okay. So, find the polynomial with the degree n that has the given zeros. So I want the degree what?
3.
3. And all I gave you was one thing. What factor did x equals 9 come from?
X plus X minus 9.
X minus 9. Cubed.
That's
So what do I have to do?
Times it out.
I have to multiply it out the correct way. And I'm stressing that because many of you on the test just would have distributed that cube, and that's not how that works. We need to end that. That's a very bad habit.
What do you mean?
You take the cube times everything.
People told me that this was x cubed minus what's 81 times 9, 729, and it's not.
That sounds
Like,
some
Those are the first and the last term, but you gotta get everything in between, right? So I got x squared minus 18x plus 81 times x minus 9.
The fact that you can do all this in
I'm not doing this in my head.
you're doing the math. You're adding everything. Are they just gonna be on our assignment?
Things like that, yeah. And then what? Mine. So I got x cubed negative.
9x.
Now I got 9, so
27.
27. Plus, I'm thinking I did my multiplication right. You guys can check. But 233x minus 729.
Well, dang.
Okay. So you just gotta take your time to multiply it out. You can multiply 9 times 81 in your
I
head.
can't do that. I'm not.
No, I can't.
Yes, you can. What's 9 times 1?
9, and then you carry
What's
over
8
72.
times? What's 8 times 9?
72.
So 729.
Yeah, but then when you have to carry, like, wait.
There's no carrying.
I know, but
81.
like when you have to carry a
Oh.
number over, I can't do it in my head.
You'll get better at it. And you don't have to do it in your head. You can write it down in your paper. You'll get better at it. You'll do it more and you'll get better at it. Okay, so the next one, we are not going to work out the whole thing on the next one. We're just going to write the first part of it like this. And then you can do it because I want to get over your test, okay? So I have this to the 4th degree. Am I going to have any double zeros? I'm not going to have time to do your test. We're going to have to start with that first thing tomorrow. Am I going to have any double zeros?
I don't know.
No.
I have a 4th degree and I have 4 zeros. Am I going to have any double zeros?
Yes.
No, you can have any more than 4.
I can't have any more than 4, can I?
I don't know how you can find that out.
Because I gave you a rule. Clear back here.
Okay, look at the beginning.
So when you do the n minus 1.
At most, n real zeros. So if I said the degree was 4 and I gave you 4 zeros, are there going to be any double zeros?
No.
No. You go past it? Okay. So I don't have any double. Here I said n was 3, yes?
Yeah.
And I only gave you 1 0, so did I have to add
Yes.
in 2 more? Yes. Okay, so what factor did that come from?
X plus 4.
What factor
X
did the
plus 1.
x plus 1,
X minus 3.
x minus 3,
X minus
and x minus 6. I multiply these two, and then my 2 answers I multiply again. Yes? And I'll tell you what these two are so you can get that far, but I think I have one more slide.
Can we combine like terms in the first part?
There isn't. Well, yeah, when you FOIL that out, you should combine it to x squared plus 5x plus 4. And then you should get x squared minus 9x plus 18.
Okay, got that part. And then we times those.
Then
together?
you times those two together. And that's just a procedural distribute. Okay, I am going to put the next slide up. So if you want to go see it, it's just a recap of what we did. So if you want to go write this down, it will be on the video. Okay? It's just a recap of everything we did. There's no more examples. There's no more anything
So the
else.
last one was the first part be x to the 4th. So much.
Yes. Yes, yes.